Hey crazies, I'm here to burst your bubble again. This picture of the atom is wrong. The real atom is far weirder than we ever could have imagined. So weird that we had to rule out everything else before we could accept it. And judging from the length of the video, you can see we're gonna take our time with this. Alright, we can't really understand where we are until we see where we've been. To the timeline! Debates about atoms have been going on since ancient Greece. Democritus first suggested that matter was made of tiny invisible bits. He called them atomos because he thought they were indivisible. This is why we call them atoms today. Of course, Aristotle thought it was a stupid idea. I still do. Why did I make you? Anyway, the debate raged on for over 2,000 years. Finally, the 20th century was fast approaching and we made some headway. Thomson discovered the electron in 1897 and proposed a simple model of the atom in 1904. Negative electrons floating in a positive mist. Rutherford proposed a better one in 1911 with an atomic nucleus, but he wouldn't discover the proton until 1919. Unfortunately, that nucleus couldn't be made of just protons. That wouldn't predict the masses on the periodic table. We had to wait until 1932 for the discovery of the neutron to explain it. Neutral particles are really hard to find. Alright, what do we know so far? Negative electrons are on the outside, surrounding a positive nucleus. That nucleus is made of protons and neutrons. But by the time we knew about neutrons, we already knew electrons didn't orbit like this. This picture is wrong. So what does it really look like? Well, it looks like this. But that's probably not what you were hoping for. Isn't there like a visual model or something? Like this, but more accurate? Okay, I'll give it a shot, but prepare to have your mind blown. Things got really weird in the 1920s, so let's try to keep this as concrete as possible. You are all seeing me because light is emitted by your screens. We saw in a previous video that individual atoms can emit light too. It's called an emission spectrum, and it can tell us what kind of atom it is. Any model we come up with for the atom must explain that. Let's start with the most obvious question. How do atoms emit light? Energy levels. Say we have hydrogen gas in a closed glass tube. If we run a bunch of electricity through it, the electrons will absorb some of the electrical energy. When those same electrons fall back down, the energy gets emitted as light. There's a slight problem though. If that electron could jump to any energy, it could emit any color of light. But we know it only emits these 4 colors. 1 red, 1 blue-green, and 2 violets. The only conclusion? That electron can't have any energy at once. It can only have specific energies called energy levels. And jumps between those levels emit or absorb specific colors of light. We number these levels 1, 2, 3, 4, 5, etc., all the way to infinity. The electron isn't allowed to be anywhere in between them, not even for a moment while it jumps. It must disappear from one and reappear on the other. I know, crazy, right? Anyway, back to hydrogen. The 4 jumps for hydrogen's visible spectrum are 3 to 2, 4 to 2, 5 to 2, and 6 to 2. Any other jump emits light that isn't visible. But why though? That's the question that takes us straight into madness.
My name is Professor Michio Kaku. I'm a professor of theoretical physics at the City University of New York, and I specialize in something called string theory. I'm a physicist, and some people ask me the question, what has physics done for me lately? I mean, do I get better color television? Do I get better internet reception with physics? And the answer is yes. You see, physics is at the very foundation of matter and energy. We physicists invented the laser beam. We invented the transistor. We helped to create the first computer. We helped to construct the internet. We wrote the World Wide Web. In addition, we also helped to invent television, radio, radar, microwaves, not to mention MRI scans, PET scans, X-rays. In other words, almost everything you see in your living room, almost everything you see in a modern hospital at some point or other can be traced to a physicist. Now, I got interested in physics when I was a child. When I was 8, a great scientist had just died. I still remember my elementary school teacher coming into the room and announcing that the greatest scientist of our era has just passed away. And that day, every newspaper published a picture of his desk, the desk of Albert Einstein. And the caption said, I'll never forget, the unfinished manuscript of the greatest work of the greatest scientist of our time. And I said to myself, why couldn't he finish it? I mean, what's so hard? It's a homework problem, right? Why didn't he ask his mother? Why can't he finish this problem? So as a child of 8, I decided to find out what was this problem. Years later, I began to realize that it was the theory of everything, the unified field theory, an equation that would summarize all the physical forces in the universe, an equation like E equals mc squared. That equation is half an inch long, and that equation unlocks the secret of the stars. Why do the stars shine? Why does the galaxy light up? Why do we have energy on the Earth? But then there was another thing that happened to me when I was around 8 years old. I got hooked on the Saturday morning TV shows, in particular, Flash Gordon. And I was hooked. I mean, every Saturday morning, watching programs about aliens from outer space, starships, ray guns, invisibility shields, cities in the sky. That was for me. But after a few years, I began to notice something. First of all, I began to notice that, well, I didn't have blonde hair and blue eyes. I didn't have muscles like Flash Gordon, but it was a scientist who made the series work. In particular, a physicist. He was the one who discovered the ray gun, the starships. He was the one who created the invisibility shield. And then I realized something else. If you want to understand the future, you have to understand physics. Physics is at the foundation of all the gadgetry, the wizardry, all the marvels of the technological age. All of it can be traced to the work of a physicist. Most of science fiction is, in fact, well within the laws of physics, but possible within maybe 100 years. And then we have impossibilities that may take 1,000 years or more. That includes time travel, warp drive, higher dimensions, portals through space and time, stargates, wormholes. You know, if you were to meet your great-grandparents of the year 1900, they were dirt farmers back then. They didn't live much beyond the age of 40 on average. Long-distance communication in the year 1900 was yelling at your neighbor. And yet, if they could see you now with iPads and iPods and satellites and GPS and laser beams, how would they view you? They would view you as a wizard or sorcerer. However, if we can now meet our grandkids of the year 2100, how would we view them? We would view them as gods, like in Greek mythology. Zeus could control objects around him by pure thought, materialize objects just by thinking. And their perks being a Greek god, Venus had a perfect body, a timeless body. And we are beginning now to unravel the genetics at the molecular level of the aging process. And then Apollo, he had a chariot that he could ride across the heavens. We will finally have that flying car that we've always wanted to have in our garage. By the year 2100, we will have the power of the gods. To paraphrase Arthur C. Clarke, any sufficiently advanced technology is indistinguishable from divinity. So let's now begin our story. The history of physics is the history of modern civilization. Before Isaac Newton, before Galileo, we were shrouded with the mysteries of superstition. People believed in all sorts of different kinds of spirits and demons. What made the planets move? Why do things interact with other things? It was a mystery. So back in the Middle Ages, for example, people read the works of Aristotle. And Aristotle asked the question, why do objects move toward the earth? And that's because, he said, objects yearn to be united with the earth. And why do objects slow down when you put them in motion? Objects in motion slow down because they get tired. These are the works of Aristotle, which held sway for almost 2,000 years until the beginning of modern physics with Galileo and Isaac Newton. When the ancients looked at the sky was full of mystery and wonder. And in the year 1066, the most important date on the British calendar, there was a comet which sailed over the battlefield of Hastings. It frightened the troops of King Harold, and a young man from Normandy swept into England and defeated King Harold at the Battle of Hastings, creating the modern British monarchy. But the question is, where did the comet come from? What was this comet that mysteriously paved the way for the coming of the British monarchy? Well, believe it or not, that same comet, the very same comet that initiated the British monarchy, sailed over London once again in 1682. This time, everyone was asking the question, where do comets come from? Do they signal the death of the king? Why do we have messengers from the heavens in the sky? Well, one man dared to penetrate the secrets of comets, and that was Isaac Newton. In fact, when Isaac Newton was only 23 years old, he stumbled upon the universal force of gravitation. According to one story, he was walking on his estate in Woolsthorpe, and he saw an apple fall. And then Isaac Newton saw the moon. And then he asked the key question which helped to unlock the heavens. If apples fall, does the moon also fall? And the answer was yes. And that answer overturned thousands of years of mystery and speculation about the motions of the heavens. The moon is in free fall. Just like an apple, the moon is constantly falling toward the earth. It doesn't hit the earth because it spins around the earth and the earth is round, but it's acting under a force of gravity. So Newton immediately tried to work out the mathematics, and he realized that the mathematics of the 1600s was not sufficient to work out the motion of a falling moon. So what did Isaac Newton do? When he was 23 years old, not only did he stumble upon the force of gravity, but he also created calculus. In fact, he created calculus at the rate at which you learn it when you're a freshman in college. And why did he create calculus? To calculate the motion of a falling moon.